So basically, we are going to discuss today the first lecture on module 2, reactions. How to find out reactions of statically determinate beams. We'll discuss later on what is statically determinate beam. And a typical example of statically determinate beam, simply supported beam under point loads, the simplest form of loads we can discuss today. So after today's class, what you will learn to do, I can show you here. You can see the today's lecture outcome. Number one, you can explain after today's class how we can apply the equilibrium conditions for a particular beam. Fine. And after that, you could illustrate the effect of different magnitudes and positions of point loads on a simply supported beam, and what will be the consequence as reactions from the particular beam. So these are two initial lecture outcome, and ultimately this is the goal. You can determine the support reactions for simply supported beams under point loads anywhere. It could be multiple point loads, it could be singular point loads, anywhere on the beam. So these are my lecture outcomes for today's class. Okay, so let us start with the definition. What is statically determinate beam? A statically determinate beam is a structural member in which all unknown reactions and internal forces can be determined solely using equations of static equilibrium. So as we discussed earlier, and we could also discuss today, uh, if we have number of equations available for equal number of unknowns or unknown variables, we could solve those equations. Suppose I can show you here that if I have an equation x 3x plus 2y is equal to 4. So you can see 3x plus 2y is equal to 4. You have two variables, but you have only one equation. Could you solve this? No, you can't. So the notion comes that to solve these two variables, we have to have, suppose 2x minus y is equal to 8. So we have to have two equations. So to solve two unknowns, we have to have equal number of equations should be available there. So similarly, when we are asking about determinate beams, the unknowns are the reactions of the beam. Fine. Suppose this is pin support and this is roller support. Roller support have one reaction, pin support have two reactions. So total number of unknowns are equal to 3. 1 for roller and it is in vertical direction, and 2 for pin support. These two reactions are in one in vertical and another in horizontal direction. So total number of reactions are 3. So total number of unknowns here are 3. Let me symbolize these unknowns. Suppose these 2 points are A and B. So I can write this one as A, R, A. The first suffix is where your reactions are acting, and the second suffix in which direction it is acting. So it is RAV. You can easily write down this as RBV, and this one will be RAH, H for horizontal direction. So these three unknowns are there. To solve these three unknowns, we have to have three equations. So where from we could solve these three equations. We could generate these three equations from the equilibrium conditions. So equilibrium conditions means since I am in equilibrium, I am not moving downwards or moving upwards because the load, suppose I have 70 kg of weight. So I am giving the floor exactly 70 kg of loading in vertical direction. And the floor is exactly giving the reaction of 70 kilogram only. For a typical condition, like if the floor is giving more than 70 kilo of reaction, what could be the consequence? Yes, I could move upward direction. If the reaction is less than 70 kilogram, I could move in downward direction. So, to be in vertical equilibrium, all the vertical forces must be equal to 0. So this is the equilibrium condition 1. Summation of all vertical forces in should be equal to 0. Then summation of all horizontal forces should be equal to 0, and summation of all moments about a particular point should be equal to 0. So these three equilibrium conditions will give us the equations to solve these three unknowns, and the structures which could be those structures where we could solve all the unknowns reactions by applying equilibrium equations are called statically determinate structures. So again I can show you that what is statically determinate structure. A statically determinate beam or structure is a structural member in which all the unknown reactions and internal forces are like shear force, bending moments, could be or can be determined using the equations of static equilibrium as I have shown to you. So next, I have already told you that statically determinate beams, when it will be statically determinate beams, when the number of reactions is exactly equal to 3. And if the number of unknowns are more than the equations available to us, then the structure will be termed as statically indeterminate structures. And the number of unknowns greater than 3 will be termed as degree of indeterminacy. Now you can ask the question, sir, what would be the other case, the third option, that if your number of equations are less than 3, then what we could say? Then the condition will appear like that. The structure would be unstable itself. It could not be stable under any loading circumstances. I will show you right now. Okay. So here you can see R is equal to 3. So as per our concept, if number of reactions are exactly equal to 3, then the structure is a statically determinate structure. So this structure, this is a simply supported beam where one end is a pin and another end is roller. This is a statically determinate structure, and we will discuss today how to calculate these unknowns by applying equations of equilibrium. Uh, this is the ultimate goal of today's class. Now let us discuss for a fixed support beam, like uh, simplest uh, form of a particular beam, it's typically termed as cantilever beams. Okay. So one end will be fixed and another end will be free. Fine. Now you can see what will be the number of reactions. For fixed support, there will be 3 reactions. One in vertical direction, one in horizontal direction, and another one, this is the third one, is called moment reaction, which is not present in roller or pinned supports. Fine. So again, the number of reactions 1, 2, and 3. So again, cantilever is a statically determinate structure. Fine. Now let us move to an example where you can find statically indeterminate structures. Fine. Now let me draw a continuous beam. Fine, where multiple supports could be there. So now you can see there are three span of this particular beam. One end is pinned and the other three are supported by ruler. So you can see now number of reactions for pinned support, as we have discussed, two, one vertical, one horizontal. For ruler, one, again one, again one. So what are the total number of reactions? 3 plus 2, 5. And this is greater than 3. So this continuous beam is a statically indeterminate structure. And R minus 3 is the degree of statical indeterminacy. R minus 3 is degree of statical indeterminacy. Fine. So here it will be 5 minus 3. So this structure is statically indeterminate of 2 degree. Fine. 2 degree of indeterminate. So this is the concept of statical determinacy and indeterminacy of simplest form of beams. Fine. Now we could go our lecture, and you can see here I have shown a diagram where you can see pin support. As we have discussed, there are two reactions. You can see the sketch, and reactions are one vertical and one horizontal. For roller support it is 1, for fixed support it is 3. And what are the constraints? Actually, reactions means restraints or constraints the support is providing to the structure. So this will be discussed later on. Internal hinge I have not discussed today. First, what we have discussed till now, I have some questions. Identify reaction components of a beam supported by a pin at A and roller at B. Determine whether the beam is statically determinate. Now you can A support is pin and B support is roller. You are asked to find out whether it is determinate or indeterminate beam, whether we have already discussed it. Okay. Let me go for an example how to solve these equations. Let me erase this one. Fine. A point load W is given at a distance A from left end and B from right end, and total length, let it be L. So I have to find out reaction at AB, reaction BB, and reaction RH. Applying equations of equilibrium, summation, first equilibrium equation, summation of all vertical forces equal to 0. Fine. So what are the vertical forces? W is acting downward, and RAV and RBV are acting upward. So as I have shown, upward direction forces are positive. So RAV plus RBV equal to minus W. W is acting downward equal to 0. Then summation of all horizontal forces equal to 0. So RAH equal to 0. And taking moment about A equal to 0, you can see clockwise moment is taken as positive. So moment means load into perpendicular distance. If we take moment at A equal to 0, you can see due to this W load and RBV, there will be moment. There will be no moment due to RAV and RAH because these two reactions loads are acting through this point A. So RBV into L, load into distance. Now we have to find out whether it will be clockwise or anti-clockwise. I can put my pen here, and if this load is actually moving anti-clockwise direction, fine. So this RBV will tend to move this A point in anti-clockwise direction, so it will be negative. And you can see this W load will try to move this A point clockwise direction. Fine. So this is A and B. Fine. So you can see W into A plus W into A will be clockwise equal to 0. So RBV equal to minus WA by minus L. So ultimately minus minus will be cancelled. So it is WA by L. So RBB is WA by L. So RAB from equation 1, you can, so this will be equation 1, 2 and 3. So from equation 1 you can find out RAB. RAB will be RBV minus W by L. So it will be W minus RBV. RBV means WA by L. So you can write WL minus WA. You can see, no? So ultimately W, if you take W as common, so RAV becomes W into L minus A by L. And L minus A means this one is L and this one is A. So L minus A is exactly equal to B. So WB by L is equal to your RAV. So you can now write this condition. RBV is WA by L and RBV is WA by L and RAV is WB by L. So just the complementary thing. So RAV is WB by L and RBV is WA by L. So now you can find out reactions for any numerical value. Suppose a point load is there and RH is 0. There is no, because there is no active horizontal forces, there will be no reaction. So suppose now 10 kilonewton is there. This is 2 meter, this is 2 meter. So you can find out the reaction. This one is RBV. You can write W into A by L, isn't it? So this one is A, this one is B. So W is 10 kilonewton, A and B are equal. So it is 2 divided by L is 4. So this is 5 kilonewton and exactly this one also will be 5 kilonewton. Fine. So this one is also 5 kilonewton. Now I will show you the some problems I have given, you are going to solve these 5 problems. You can take a screenshot of this particular figure and solve these 5 problems. A simply supported beam, all are simply supported beam, except this question number 5, all are very simplest in form. This 18 kilonewton will act at an angle of 60 degree. There will be some horizontal component will be there. I will check whether you could solve this or not. We'll discuss in our next lecture. Before that, this is your home assignment you can take. Thank you for today.